The purpose of this video is to demonstrate the SovLabs Custom Naming module for vRealize automation. Many organizations depend on server naming standards. Naming standards help IT and application teams quickly identify and categorize any given server by criteria important to that organization. A server's function, role, operating system, environment, or other attributes can be components of an organization's naming standard. The SovLabs Custom Naming module for vRealize automation allows you to create independent, data-driven naming sequences and standards so that servers provisioned through vRealize automation will adhere to specific naming conventions. The SovLabs Custom Naming module for vRealize automation helps you create flexible naming standards that include one or more sequences that consist of a mix of static text and dynamic content such as vRealize automation custom properties and/or custom logic. The module will validate host names with both DNS and the vRealize automation database to ensure a name is not already in use. Thanks to selective locking, virtual machines provisioned in parallel will not generate conflicting host names. The module includes the option to reuse sequence values, such as when the host names would be made available when a server is decommissioned or the spaces can be left intact. Sequences can be updated at any time for scenarios like increasing a sequence length or setting a new initial value. To use the SovLabs Custom Naming module for vRealize automation, we must first define a SovLabs naming sequence. Let's take a look at a common naming sequence. First, we pick a label for the naming sequence. Next, you can see we have several options for the sequence: decimal, hexadecimal, octal, and pattern, which can also use binary, A, B, or any of the aforementioned types in any combination. For the purposes of this demonstration, we're going to use decimal. You see that we have the ability to reuse sequences. Let's say you have 5 host names labeled 01 through 05. If you decommission 03 and 04, you can either reclaim them or leave those types of gaps as they occur. The max sequence length refers to the number of digits that will comprise a hostname sequence. 2 and 3 are popular options. The initial value is the number you'll use to start your naming sequence. The sequence padding allows you to select the digit that you'll use for padding the numerical portion of your sequence. You'll see we have an item called the unique key. We'll come back to this in a moment. Now that we've defined our naming sequence, let's define a naming standard. In our naming standard configuration, we'll refer to the naming sequence from our previous step. As we look at the template itself, we see several interesting things. First, there's a pattern at the beginning of the name we arbitrarily define that is comprised of 3 letters. This is static and unchanging. Please note the usage of the double curly braces indicates usage of the SovLabs template engine. After that, we utilize a variable CentOS7_env_dropdown, which is based on a VRA custom property we defined in the blueprint. And we used VRA's property dictionary feature to present the user with a dropdown related to the environment. We also have a variable based on the type of application on the server. After that, we have the OS as a variable. Finally, we have the numerical sequence we defined in the previous step. Now let's return to the concept of the unique key from the previous step for just a moment. The unique key is an extremely powerful option. By using vRealize automation properties in this sequence, you can allow variations on your hostname by region or environment without creating multiple naming sequences. Let's consider the following example. Let's say you have a hostname that is defined by region like development or production, an operating system, and an application like this, prod-linux-app01. If you present the user with a choice on region at provisioning and they pick development, using our unique key, the resulting hostname would be dev-linux-app01. If they used quality assurance as the region, then the hostname would be qa-linux-app01. For this to work as described, our naming standard template must match our unique key so that individual unique combinations of dynamic data and corresponding sequences are stored in the sequence data section and can be individually edited. As you can see in our example, the unique key in the naming sequence does match the template field in the naming standard. This is so that these predictable deviations based on vRealize automation properties can be derived consistently. Let's provision some servers and watch what happens. We will provision one of each type of server using all of the first, second, third, and fourth variables in sequential order so that we effectively have 3 servers with 3 names that all follow the same standard. As expected, the hostname assigned to the servers are unique and fits the naming standard we defined. Now, we'll update this particular rendered sequence, changing the next assigned value to 19 and then provision a server using the same variables which result in a hostname that will end in 19. The server we just provisioned utilized the same variables in the previous rendered sequence we modified and now ends in 19. All subsequent server builds using the same variables will increment, and the next build would end in 20, and so on. To recap what we've just seen, the SovLabs Custom Naming module for vRealize automation can do all of the following. It creates flexible naming standards that include one or more sequences. Naming standards can consist of a mix of static text and dynamic content such as VRA custom properties and/or custom logic. It validates against DNS and the VRA database to determine hostname availability. It includes advanced selective locking, preventing duplication of hostnames with parallel provisioning without sacrificing performance. It allows for creation of multiple types of sequences such as decimal, hex, octal, binary, AB, or custom pattern. Dynamic sequences are possible using the pattern type, which can utilize VRA properties in combination with custom logic and one or many sequence types. It includes options to allow for reuse of sequence values, for example when gaps are left when machines have been deprovisioned. It includes options for sequence length, padding character, and initial value. Sequences can be updated at any time for scenarios like increasing sequence length or setting a new initial value. For example, you can set the next sequence value at 500 instead of 30. It supports creation of multiple naming sequences and standards as needed, and it's a simple two-step install and upgrade process. For information on this and all of our other vRealize automation modules, please visit SovLabs.com.